Hello everyone. So in the last class we discussed in the last class we discussed about the physical properties of alkanes and sources of alkanes, where exactly alkanes come from. Now in this video we will be discussing the chemical properties or the reactions that alkanes take part in. Specifically, in this video, we will be only covering two out of the three reactions that alkanes take part in, being combustion, cracking, and free radical substitution. Now, combustion, as we know, is the reaction of a hydrocarbon with oxygen when it is burnt in oxygen. Now, this is the general formula of complete combustion for an alkane's reaction with oxygen. Now let's take some examples so you understand this entire general equation a bit better. Now what if your x is 1? The value of x is basically any integer, okay? So x can be 1. If x is 1, then y will be 4. It will be 4 because the general formula of an alkane is CnH2n plus 2, right? So if CH4 is your first alkane and you are reacting that with oxygen, your products should be carbon dioxide and water. Now let's balance this equation. We should get a 2 over here with the oxygen, and we should get a 2 over here with the water, and this is balanced, right? Now what if we use this general equation, this general formula, and apply that over here? If x is 1 and if y is 4, then let's check this out. Let's check this out. Will x plus y upon 4 give us the correct answer? It should, right? So let's see. 1 plus 4 upon 4, which is 1 plus 1, which is 2. And can we see that that is exactly what we got? Then again, x should come over here. X is 1, so 1 is what is coming over here, right? We just don't typically write 1 conventionally, but it is over there. Now the last one, y upon 2. Can we see that y is 4? So 4 upon 2 should give us 2, and that is exactly what we are getting, right? So this is the general formula for complete combustion of alkanes. Complete combustion means that carbon dioxide and water will be produced. And remember, keep in mind that combustion is always an exothermic reaction. That is a point to remember. Okay, now over here you can see the first 5 alkanes and their combustion reactions, and you can see the general formula being applied over here, and you can try it out by yourself also as an exercise, and you will see that these balanced coefficients are exactly what you are going to get if you apply the general formula directly. So to save time in the exam, or if you are under a time constraint, it would be advisable to revise the balanced formula, to revise the general formula. Okay, so if you could just go through these reactions if you wish to, you can, and you will see that they all follow that general formula. Okay, now moving on to incomplete combustion. Now what exactly incomplete combustion is, we'll go through that. There are 3 cases of incomplete combustion that can take place. Complete combustion takes place when there is an excess of oxygen, when there is a lot of oxygen present for the alkane to burn in. So that results in carbon dioxide and water being produced. But what if there isn't enough oxygen? Now, if there is less than the required oxygen for combustion, then incomplete combustion will take place, and that is this first case. In this case, you will see that instead of the only products being carbon dioxide and water, there will be three products that you are getting. You will get carbon dioxide, carbon monoxide, and water. So carbon monoxide is a result of incomplete combustion, and when this reaction happens, you will see that there will be a black or a sooty flame from the experiment. Okay, that is what is a result of incomplete combustion. The second case of incomplete combustion occurs when there is even lesser oxygen provided. So first there were 4 moles of oxygen provided, now there are 3.5 moles of oxygen provided, so lesser moles. Then that would result in no carbon dioxide being formed, instead carbon monoxide and water will form. Okay, and then the final case of incomplete combustion is when there are 2 moles of oxygen. Now this varies from alkane to alkane. Okay, this alkane is propane. We are using an example of propane being burned incompletely. So that results in the transition from 4 moles to 3.5 moles to 2 moles. But it differs from alkane to alkane. Now in this what happens is, since even lesser oxygen is being provided, there is only carbon, elemental carbon being produced, and water. So you can see from the transition, at first your carbon containing products were carbon monoxide and carbon dioxide. Then you had only carbon monoxide, and then you had only carbon. So you can clearly see that oxygen is being removed gradually as you decrease the oxygen. Okay, so this is incomplete combustion. Now this is all that you need to know about combustion. Okay, and this is the first type of reaction that alkanes take part in. Now moving on to the second set of reactions, which is cracking. There are two types of cracking in our syllabus. The first is catalytic cracking and the second is thermal cracking. Catalytic cracking has some conditions that are a prerequisite. Okay, the first being that it has to have high temperature. High temperature is a prerequisite. Okay, and then it also uses a catalyst, and the catalyst is either aluminium oxide, which has the formula Al2O3, or silicon dioxide, which is SiO2. Any of these formulas can be, any of these catalysts can be used. There is no such preference to our syllabus. Okay, so you can use any of them. Now over here you can see examples of reactions. We have reacted hexane, and hexane is basically getting cracked into smaller products. Now what exactly is cracking? Cracking is basically a process that an alkane undergoes, and not just any alkane, large chained alkanes, meaning alkanes that have a lot of carbons in them. They are basically cracked to break down the alkanes into smaller alkenes and alkanes. At least for catalytic cracking, this is the case. And this occurs so that they are more commercially used and to produce more useful products. Because as such, we don't have a demand for large chained alkanes. So that is why cracking takes place, and this only takes place when certain conditions are met. Now an example of hexane is given over here, and we are using the Al2O3 catalyst, and the high temperature is 500 degrees Celsius. And then we can see that an alkane and an alkene is being produced. The alkane being produced is butane, and the alkene is ethene. Okay, so we can clearly see this. Then another example is of an 11 carbon chained alkene, and in that we can again see that aluminium oxide is being used and 500 degrees Celsius. The alkane produced is octane, and the alkene produced is propene, and so this is how it goes. Okay, now on this side of the page I have written the same alkane, a 12 carbon chained alkane, and I have written 4 different reactions for it. Now we will basically see that this can be written in 4 different ways. Okay, meaning there is no set alkane or alkene that is going to be produced from this. You can produce any length of alkanes and alkenes that you wish to from these. Okay, so the first one that I would produce is C6H12, and whatever is left over, there are 6 carbons left and there are 14 hydrogens left, right? So that produces hexane and hexene from this. This is hexene and this is hexane, right? So we can clearly see that an alkane and an alkene is produced. Then we can produce an 8 carbon alkane and the corresponding alkene, and you can name them as you wish to. The C8H18 would be octane, and then this would be butene. So let's name it if you wish to. Then moving on, the next type that I would wish to is to use the same product C8H18, and I can produce 2 moles of ethene, right? In this case also I am producing an alkane and an alkene. And then the last type that I would produce from this is a 7 carbon alkane and a 5 carbon alkene. So this entire example is just to show you that the same long carbon chained alkane can be cracked to form different types of products, whichever is required in demand. Now in the next video we will be discussing thermal cracking. Thank you.